Hey, I'm Dave from Matter Hackers, and this is Ultrafuse 316L from BASF 3D Printing Solutions. BASF 3D Printing Solutions had Matter Hackers test Ultrafuse 316LX, their R&D version of the exact same material, Ultrafuse 316L. The time is here to explore easy and affordable metal 3D printing. It is now possible to print 3D printing has been around for a few decades now and is well established, but generally limited to thermoplastics. Similarly, metal injection molding is now a commonplace as a manufacturing process. You most certainly have used tools or devices that have metal injection molded components in them. Now, 3D printing and metal injection molding are joining forces to introduce metal 3D printing to the desktop market in Ultrafuse 316LX. Ultrafuse 316LX is a metal polymer composite filament developed by BASF 3D Printing Solutions team to produce metal components in actual stainless steel type 316L using standard 3D printing processes and subsequently an industry standard debinding and sintering process. This material was created specifically to make it easier, faster, and more affordable for any businesses or engineers using traditional manufacturing methods like CNC milling or even metal injection molding. Maybe you already have a desktop 3D printer and are looking for more strength and durability from real metal parts compared to the plastic you may be using today. That's where we fit in. We've succeeded many times over with printing, iterating, and designing parts that then got sent out for debinding and sintering, and we've received back beautiful, durable metal components. I want to take a moment to guide you through the most important considerations when looking to succeed with this material. And the first is designing for additive. You'll be 3D printing these parts, so you want to make sure you're designing for that manufacturing method. And 3D printing is absolutely a manufacturing method that has its own considerations. So if you're CNCing a part or metal injection molding a part today, you'll want to make sure the design considerations for 3D printing still apply to those parts. Next, the part should be flat on one side. The printing process itself relies on the material's adhesion to the bed surface. This ensures there's no warping, especially while the part is cooling on the bed. You also have to design with a high width to height aspect ratio. When designing parts for sintering, it's good to consider the strength of a part at its weakest state, a brown part, after debinding. At this stage, the more stable you can make the design, the more likely the part is to go through the sintering process intact. For this reason, designs that are wider than they are tall, think pancake instead of tower, are often more successful. This isn't to say you cannot succeed with those type of designs, but it takes some experience and consideration. It's also important to design features to be generally homogeneous. This is a fancy way of saying don't have drastic variations in your part thickness. Similarly, avoid thin walls. Thin walls can delaminate during the sintering process, so be sure you use a minimum wall thickness of 1.5 millimeters. That's a good place to start. Another thing to avoid are overhangs. For best results, overhangs should be 50 degrees or steeper. This prevents the material from sagging during the sintering process. Lastly, keep parts within a 100 millimeter cubed build volume. Now that you have your parts designed and you're preparing the model for 3D printing, it's important to note that these parts will shrink anisotropically. For that reason, you'll want to scale your model to be sure that the part you receive back is to the dimensions you're expecting. And here's the proper scaling to make sure that's successful. In order to print with Ultrafuse 316LX filament, your 3D printer will need to be equipped with the proper components. For instance, a heated bed capable of at least 100 degrees Celsius, a glass bed with Kapton tape or Dymafix bed adhesive, and a hardened steel nozzle. Now that we know your hardware is capable of printing this material, let's talk about the print settings themselves. Set your heated bed temperature to between 100 and 120 degrees Celsius. The hot end temperature should be 230 to 250 degrees Celsius, but not to exceed that 250. Go ahead and turn your part layer cooling fan off because this could actually induce warping during the printing process. We recommend a layer height of as small as possible, even starting at 0.1, to ensure better part quality and, more importantly, higher density of the material. Print speeds of 15 to 40 millimeters per second are a great place to start. You can certainly go faster with that, but low and slow is always the best place to begin. And lastly, infill. Set it to 100%. When you start your 3D print, it's critically important that your first layer is perfect and your extruder is calibrated. Any errors in the first layer could propagate and result in poor part quality. Any gaps or voids on account of your extruder not being calibrated could lead to failures during the debinding and sintering process. The part you remove from your 3D printer is called a green part. In this state, it's very easy to clean up and is relatively soft. Remove any brims, clean up any printing artifacts that may have been left from the printing process. A razor blade, deburr tool, or even a small file set are recommended for this cleanup. It's much easier to clean up these parts in their green state than when returned as sintered metal parts. If any warping occurred during the 3D printing process, now is a good time to sand that surface flat. Lapping the bottom surface will have the part processed through the debinding and sintering steps with greater feature and dimensional stability. It's important now to remove any contaminants, oils, fingerprints, bed adhesives, because the contaminants can cause failures during the debinding and sintering processes. Now you have your printed green parts ready for debinding and sintering. BASF 3D printing solutions, with the help of their distribution partners, have made it really fast and really easy for this stage of the process. They're setting up a network of debinding and sintering services. So you package up your parts, send them out, and very quickly they come back fully debound, sintered metal parts. You now have your parts back from sintering, and these are full metal stainless steel 316L parts. You can process them any method that you'd like. You could grind for material removal, polish in any method you see fit, or even CNC machine these for higher tolerance features. If you, your business, or manufacturing process are looking to rapidly create prototype or production metal parts without the setup costs and time of traditional manufacturing methods, then Ultrafuse 316LX is for you. Using this material on a standard desktop 3D printer is a cost-effective alternative to typical subtractive methods or setup and tooling costs for metal injection molding. To learn more about Ultrafuse 316LX, go to BASF's 3D Printing Solutions website or visit matterhackers.com for more in-depth guides on how to succeed with this material.